Okay, Wildcats. Today we're going to journal page 49, solving square root inequalities. Solving square root inequality steps. Step 1, isolate the square root. Step 2, raise both sides of the equation to the power of 2. Step 3, simplify and solve. Step 4, consider the radicand. The radicand must be greater than or equal to 0. Step 5, graph the solution. Step 6, state the solution. Okay, so if you would, complete your notes. Now your notes are complete. Let's take a look at the examples. Okay. All right. Solve each inequality. Okay. Step 1, isolate the square root. The square root's isolated. Step 2, we're going to square both sides. Okay. Now, when you square root it, unsquare roots it, so you're left with 2x plus 4 less than or equal to 4 squared is 16. Okay. Now we're going to solve for x, so subtract 4 from both sides. And let me brighten the screen up just a little. There we go. So subtract 4 from both sides, so that's 2x less than or equal to 12. Divide both sides by 2. X is less than or equal to 6. Okay. So here, 0. Okay. Now, we know that positive 6 is to the right of 0, and it's a closed circle because there's a line underneath. Okay. Now, we think of the inequality as an arrow. As long as the x on the right or the left side, we can see that it's like an arrow just pointing to the left, so we shade to the left. Okay. But we can't forget about the radicand. So we said the 2x plus 4 has to be greater than or equal to 0. And the reason being is you can't take the square root of a negative number. So this has to be greater than a negative number, okay? So we're going to solve for x. So we subtract 4 from both sides. So you get 2x greater than or equal to negative 4. Divide both sides by 2. So x is greater than or equal to negative 2. So since there's a line underneath, we have a closed circle at negative 2. Okay, and again, we think of this as an arrow. This is telling us to shade to the right. And you want to darken the overlapping region. And so you see here our solution lies between negative 2 and 6. I'm going to overemphasize that by, let's make this big closed circle and then, okay, darken that region. Okay. Now, as an inequality, this would be negative 2 less than or equal to x, because this is the x-axis, less than or equal to 6. Okay. Separate your answers here. Oh, got blurry. And we know we're going to do that here, so let's just extend that line across, okay? All right, now let's take a look at example 2, okay? So we need to isolate these square roots. We're going to subtract 3 from both sides, so you get the square root of 2x minus 6 less than 6. Okay, and clean up that square root, straighten it up a little bit. All right, now we're going to square both sides. The square unsquare root is the square root, so that's 2x minus 6 less than 6 squared is 36. Now we're going to solve for x. So we're going to add 6 to both sides, so you get 2x less than 42. Divide both sides by 2. X is less than 21. All right. Now, we want to set the radicand greater than or equal to 0. I say, yeah, greater than or equal to 0. Now, if you notice, I'm doing example 2 slightly different here. I did this and started graphing that, and then did that, then graph. But what I'm going to do here is I'm going to find this inequality and this inequality and graph it all at once, just to show you the difference of if you want to choose to do it either way. Okay. Now here we're going to add 6 to both sides. You get 2x greater than or equal to 6. Divide both sides by 2. X is greater than or equal to 3. Now, it benefits to wait to graph till you have them both, because here you can see that they're both positive, so you can put your 0 to the left because there are no negative numbers, okay? Now, here, this is a closed circle at 3, okay, and an open circle at 21. Now, for shading purposes, this looks like we're shading to the left of 21, okay, and here we're shading to the right of 3. So here you can see that this overlaps, so that's darker, and then it doesn't overlap there. So our solution lies between the overlapping region. So inequality-wise, this would be 3 less than or equal to x, because this is the x-axis, less than 21. Okay, so go ahead and finish up example 2. All right, let's take a look at example. Well, I'll give you a second to make sure you got that. Okay, now let's take a look at example 3. Okay, so we need to isolate the square root, so we're going to subtract 3 from both sides. So you get the square root of x minus 4 greater than 6. Okay, now we're going to square both sides. So the square unsquares the square root, so you get x minus 4 greater than 36. Add 4 to both sides, you get x is greater than 40. Now we set the radicand greater than or equal to 0, so x minus 4 greater than or equal to 0. So we add 4 to both sides, so x is greater than or equal to 4. So again, you can see here both numbers are positive, so we can put a 0 on the left. We have a closed circle at 4. And we have an open circle at 40. Now shading, and let me leave space for the inequality. Okay. Shading wise, it looks like x is greater than 40, so we shade to the right of 40. Okay, because the arrow would be pointing to the right. And then here, it looks like we're shading x is greater than 4, so we're shading to the right of 4. So here, and you can see that this is the overlap. So that's your solution where it overlaps. Okay. So our inequality solution would be x greater than 40. All right, let's take a look at example 4. Okay, so the square root's isolated, so we're going to square both sides. Okay, so that unsquares the square root, so that's 2x minus 7 greater than 90 squared is 8100. Okay, we're going to add 7 to both sides, so you get 2x is greater than 8107. Divide both sides by 2. X is greater than 4053.5. Okay, now we set the radicand greater than or equal to 0, so 2x minus 7 greater than or equal to 0. Add 7 to both sides, you get 2x greater than or equal to 7. Divide both sides by 2, so x is greater than or equal to 3.5. Both numbers are positive, so we can put a 0 on the left. And we don't care the decimals. We know that the order 3.5, now it's a closed circle at 3.5. And we have an open circle at 4053.5. We don't care that numbers are decimal or large. 3.5 came first, then 4053.5. Okay, so those are right order. Right now for shading. Now it's greater than here, so we shade here. Okay. And then it's also greater than, so we shade here. It's not overlap, so we shade light. And we can see here that this is the overlap, so we shade that dark. So our solution is the overlapping shading region, so that's there. So as an inequality, we would say x is greater than 4,053.5. Okay, so finish up example 3 and 4. All right, let's take a look at example 5. Okay, and let me add this line before I forget to leave space for the inequality. All right, let's take a look at example 5. So we want to isolate the square root, so we're going to add 6 to both sides. So that's the square root of 2x less than 6. We're going to square both sides. The square unsquares the square root, so you're left with 2x less than 6 squared is 36. Divide both sides by 2. X is less than 18. Okay, now we set the radican greater than or equal to 0, so 2x greater than or equal to 0. Divide both sides by 2. X is greater than or equal to 0. But now here, in this case, it's unique in that we actually have a point at 0. And that's a closed circle. And we have an open circle at 18. Now, here, x is less than 18, so we shade to the left. And just shade light. Okay. And then x is greater than or equal to 0, so you're shading to the right. This overlaps, so we shade darker. This doesn't, so it's light. So we can see our solution is between 0 and 18. Okay, so as an inequality, that's 0 less than or equal to x less than 18. Right? So if you would, finish up your examples and start working on your assignment, and have a wonderful Wildcat day.